When most of us imagine tropical biomes, we tend to imagine that they are totally free from freezing temperatures and wintry weather. It's part of the definition, isn't it? Sure, there may be frost and snow at high elevations of tropical regions, but that's expected. Truly tropical, lowland ecosystems don't have to deal with freezes, right? Well, yes, that's often true, but there are a handful of places on our planet that defy that general rule. In this video, we're going to examine these places and look at how cold temperatures can reach deep into low latitudes at low elevations. It all has to begin with cold air masses, the coldest of which always develop over continents at high latitudes. In the northern hemisphere, the two most important ones form in winter over Canada and Siberia. And importantly, these cold air masses can move in any direction, despite prevailing wind patterns. Prevailing winds in an area are just a long-term average. The day-to-day atmosphere is much more chaotic. These cold air masses can move in any direction, depending on many factors. When they cross a deep body of water, they'll rapidly gain heat and moisture due to its high heat capacity. This leads places like Japan to have milder and wetter winters compared to mainland Asia, or even Michigan compared to Wisconsin. Mountain ranges also dramatically impede the progress of cold air masses, and any air mass that crosses them will be warmed dramatically by the Foehn effect. This is a weather phenomenon that's mostly caused by something called isentropic drawdown. Regardless, you can think of large and consistent mountain ranges like a buffer against extreme cold waves. The cold air masses from Siberia and Canada typically move south on the eastern side of the continent, for reasons that I outlined in my video, The 4 Reasons East Coasts Get Colder. This is particularly consistent during the winter in East Asia, which leads us to our first location, southern China. The port city of Guangzhou sits on the Pearl River just south of the Tropic of Cancer. It has recorded both freezing temperatures and rare snowfall, the last of which was in 2016. But this actually isn't the most ideal example. Although it is south of the Tropic of Cancer, it does not have a tropical climate. Under the Köppen climate classification system, the most common system used, it actually has the colder, humid subtropical climate. That's because cold, northerly winds are consistent in this area throughout the winter, and they pull the average temperature too low during winter to meet the tropical temperature threshold. A slightly better example exists on the other side of the world. The climate of the southeast United States has a lot in common with southern China, but a key difference is that the cold northerly winds are not consistent here in winter. Rather, they occur in random outbursts that shock people and wildlife. But there is one area that sees these cold air outbursts much less often and with much less severity: peninsular Florida. It's surrounded by warm currents on 3 sides: the loop current in the Gulf, which becomes the Gulf Stream on the east coast. As a result, the average winter temperatures in southern Florida are high enough to grant this area a tropical climate, despite the fact that it is north of the Tropic of Cancer. Regardless, southern Florida can receive some distinctly not tropical weather on occasion, but only when conditions are just right. Stuart, Florida, has a tropical rainforest climate, but has recorded freezing temperatures 5 months out of the year. Some non-accumulating snow fell in southern Florida in 1977, and there was some accumulating snow that year in areas farther north like Tampa. In all of these cases, winds came directly from the north down the peninsula due to a high-pressure system in just the right position to the northwest, or a low-pressure system to the northeast. Without this perfect setup, peninsular Florida is usually spared from serious cold when the rest of the southeast gets hit. But that isn't to say these rare cold waves are inconsequential. In fact, they leave many long-term impacts. The cold wave of 1977 killed 96% of shallow branching coral in Florida, and it still hasn't completely recovered. Each cold wave has also forced citrus growers farther south over the last century. Are there other tropical climates north of the Tropic of Cancer? Definitely. But that isn't where I would go to find examples of tropical freezes. Bermuda has the northernmost tropical climate on Earth thanks to its position far offshore and downwind of the Gulf Stream, at an amazing 32 degrees north. It actually shares many of the same coral reef and mangrove species you can find in southern Florida. But temperatures have never been freezing here or anywhere close. We have to stick to large continents to find freezing temperatures in tropical climates. Now, to be honest, southern Florida and southern China aren't exactly the best examples of the phenomenon I want to highlight. When I first asked this question years ago, I wanted to know just how deep into the tropics a cold air mass could go. Are there any places where cold air masses reach deep into tropical latitudes and affect normally tropical climates? Well, yes, there are a few places on Earth where this does occur. And there is one phenomenon that can do this with surprising efficiency. It's called cold air damming, and it only occurs on the eastern side of a north-south running mountain range. Now, cold air damming doesn't just mean cold air being blocked by a mountain range. It's a much more specific phenomenon, but the mechanism is pretty simple. A large, cold, high-pressure system develops at high latitudes on the eastern side of a mountain range. In this example, the Rockies and Sierra Madre Oriental. On the southern side of the high-pressure system, the cold air layer is dense and shallow, and it can't get over the mountain range. So the cold air pools up against the side of the mountain and is forced south, because that's the only direction it can go. As this continues, the cold air can be forced deep into low latitudes. As it moves south, it can force up the warmer, less dense air, creating freezing rain or snow if there's enough moisture in it. This is the driving force behind the worst freezes southern Texas has experienced. And they've been very severe, much more severe than in Florida. Brownsville, Texas has seen temperatures as low as minus 11 degrees Celsius or 12 degrees Fahrenheit. Compare that to minus 3 degrees Celsius or 27 degrees Fahrenheit in Miami at a similar latitude. That's why some species, like the red mangrove, can be found in Florida but are absent in southern Texas. And the effects of these freezes are wide-reaching. During the 2021 freeze, millions of fish died in coastal waters, especially in isolated water bodies like the Laguna Madre. Citrus production, including the grapefruit that's so important in Texas, gets hit hard. Non-native animals also don't do very well. The nilgai, a huge antelope from India, is one such example. They can thrive for some years in southern Texas in a free-ranging situation due to the warm average temperatures, but these freezes are devastating for them, and scientists believe this will limit their range expansion just like the freezes in Florida limit invasive pythons. And the freezes produced by these cold air damming events don't always stop in Texas. They can cross the border into Tamaulipas and even farther south into Veracruz. The cold air stays pooled up against the Sierra Madre Oriental, being pushed farther and farther south along the coastal plain. The absolute limit of these freezes seems to be about 20 degrees south, where the Trans-Mexican volcanic belt forms a physical barrier, because beyond that, the shallow, cold air layer has to cross the warm Gulf. The port city of Tampico has the distinction of being the southernmost coastal location in North America to have recorded snowfall. It's a pretty unique situation. This region as a whole is the only coastline in the northern hemisphere which is at a tropical latitude, has a tropical climate, and yet is vulnerable to rare freezes. It's the transition zone between the thorn scrub of the north and the tropical rainforests of the south, with pockets of rainforests in the mountains throughout. It's home to dozens of colorful bird species like parrots and flycatchers, as well as crocodiles. And yet it can be transformed by sudden drops in temperature. One botanist recorded the bizarre landscape of a tropical forest after a freeze. He recalled that nearly all the epiphytes, or plants which grow on trees and cliffs, were dead, especially the tank bromeliads, all turned to black goo. Which sort of begs the question, how were all those plants there in the first place? If these freezes are rare, but also inevitable, why were those species there? Well, there are probably two reasons. The edge of this region is mountainous, meaning it's rich in microclimates that serve as refugia, basically sanctuaries that can allow species to recolonize after a climate disaster. And this area is also a migratory path for birds coming out of the tropics every year, who carry tropical seeds in their stomachs. For people, too, these cold waves can do a lot of damage. This is a major area for citrus and coffee production in Mexico, and these freezes pose a major risk to their crops. Cold northerly winds, or nortes, may even be ingrained deeply into the local culture in a profound way. The Huastec people, an ethnic group still living in the area today, left pre-Columbian stone ruins throughout this region. The Huastec civilization was an offshoot of the Maya and the northernmost Mesoamerican civilization. One fascinating thing archaeologists note about them is that they placed particular emphasis on Ehecatl, the god of the wind. No one is sure why, because this isn't a particularly windy area, but I would suggest it's because the one factor which brought the most awe-inspiring and sudden change to the world around them, which quieted all the birds and insects, forced animals into hiding, and wilted the corn, was a cold northerly wind. There is one other part of the world that can match this region's bizarre climate, and it's also caused by cold air damming, thousands of miles to the south on the eastern side of the Andes. When high-pressure systems form here, spinning counterclockwise in the southern hemisphere, they form a pool of cold air along the eastern side of the Andes that forces its way north. Now, in this area, the cold air mass originates from the Southern Ocean, and because it's not continental in origin, it's nowhere near as cold as the ones from Canada and Siberia in winter. It's often mentioned that South America's southern cone has relatively mild winters for its latitude, and that's true, but it's simultaneously true that the cold air masses which affect this region can sweep up the central part of the continent quickly and easily without warming up very much. That's because this area has the perfect setup for cold air damming, even more so than North America. Not only is there a very steep, high mountain range running north to south, but there's also an almost perfectly flat plain butting right up against it. What that means is that the cold air pool can move north into the tropics with very little friction to slow it down. That's quite different from the situation in North America. It may appear flat on the eastern side of the Rockies, but there's actually a wide ramp sloping up to quite a high elevation before the Rockies. Those high plains, as they're called, add friction to air masses moving south and slow them down. And the other factor that enhances cold air damming is continentality. There's no warm Gulf of Mexico or anything like it near these mountains. So what you get is a wave of cold air sweeping north with little interruption, called the Friaje, or several other names in different regions. It's brought snow to the subtropical mountains of southeast Brazil and has made global coffee prices skyrocket multiple times by wiping out the coffee groves in Brazil's highlands. The core of this cold wind sweeps across the Chaco savanna, sweeping past the cities of the foothills. It then creeps around the corner of the Andes into the Amazon basin, bringing surprisingly cold weather even into a tropical rainforest for days at a time. Temperatures well below freezing can cross the Tropic of Capricorn, and frost can sweep across the Chaco savanna. Temperatures near freezing have even been recorded deep in the southern Amazon basin. To be fair to Tampico, Mexico, this area isn't at sea level, but it is mostly below 400 meters, which at a tropical latitude won't play a large role in dropping temperatures. There is a silver lining to these cold winds, and that's rain. In most tropical monsoon and tropical savanna regions, the dry season occurs during the winter of that hemisphere. The southern Amazon and Chaco savanna are no exception. But the Friaje can bring rain and clouds during the dry season, because it's basically just a weird cold front. It's worth mentioning, however, that this cold and wet weather can be hazardous, especially at higher elevations in the adjacent mountains. For instance, in 2003, around 13,000 cases of severe hypothermia were reported in Peru due to the cold and wet conditions brought by the Friaje. For the gauchos of the Pampas and Chaco regions, a thick wool poncho served as the traditional answer to the Friaje, a thick outer layer that can be thrown on when temperatures plummet. Like South America, the Sahara is not in a good position to receive serious continental polar air masses. It has the Mediterranean to the north, along with multiple mountain ranges, and only extends up into subtropical latitudes. The coasts of North Africa have very mild winters. Throughout the winter, high-pressure systems sit over the Sahara and send northeasterly winds down into the tropics, the harmattan. But these winds normally bring warm days, cool nights, and a lot of dust, not serious cold. When climatologists warn you about the cold of the Sahara, they're really talking about the extreme temperature difference between the day and night, especially in winter thanks to the clear desert sky. Temperatures just below freezing are not uncommon at night in the northern Sahara during winter, and the following day can be surprisingly warm. Of course, there are multiple mountain ranges in the Sahara which get very cold. All of that being said, this is a wide landmass with few barriers cutting across it, so if conditions are right, temperatures just below freezing can reach into the tropics. And this does occur in the eastern Sahara, the driest part of this vast desert. It happens when northerly winds originate not from an anticyclone over the desert, but from a cold air mass in Eurasia pouring south through the Aegean. After crossing mountains and seas, the air arrives in Egypt not freezing, but unusually cool, and under a clear night sky in the desert, these winds can drop below freezing in the eastern Sahara as they progress south, even as far south as Sudan. You can see a similar situation in northern Australia occasionally. The cold air mass that arrives in the subtropics isn't all that cold, relatively speaking, but it has a clear path over land to reach the tropics. And because it lost its moisture at the coast, temperatures fall rapidly under a clear night sky. Some other examples of cold tropical regions are sometimes listed. The coastal deserts of Peru have cool weather and stratus clouds for a large part of the year thanks to coastal upwelling, though it's never freezing. And there are many places at tropical latitudes which people don't realize are at a high elevation because they're on plateaus, which are invisible to the casual observer. These examples don't quite fit with what we're talking about today. So in these unique areas, how do the animals cope with the sudden cold? If they're normally adapted to tropical lowlands, how do they make it? Well, in a variety of ways, and some animals have a much easier time than others. Temperatures below 10 degrees Celsius are too low for most insects to fly, so insect-eating birds and bats have a pretty hard time. One ecologist in the southern Amazon reported that a few hours before the Friaje swept over him, hundreds of white-eyed parakeets flew over the canopy, heading north away from the cold wave. So maybe some species move. But most parrots tend to nest in tree cavities or holes in cliff sides, often huddling together with their friends, so they can hunker down and do just fine. In dry areas like the Chaco or the thorn scrub of Tamaulipas, there are loads of burrowing animals, and multiple species can use those burrows. Bananaquits in the Chaco and southern Amazon make perfectly woven, enclosed little nests that look like grass huts. These nests reduce their rate of heat loss by a third. In the Amazon, tree frogs descend from the upper canopy during a friaje because the understory can be several degrees warmer during that time. And even if there's an unusually late friaje in the spring, the Argentine tegu can still be active when other reptiles would be stunned. That's because they're temporarily an endotherm, or produce their own body heat like a mammal during the spring. In short, even animals in the tropics can adapt to the cold. From a conservation perspective, there's something important to consider about frost in tropical ecosystems. If you live in an area with frost, you may have noticed something in autumn. When the first few frosts arrive, many annual plants that aren't frost tolerant survive beneath trees and shrubs. It's not so much that the tree is trapping warm air from the previous day, though that can happen in a dense forest. Even in a very open area, just one tree canopy makes a huge difference to the area right underneath. That's because on a cold night, surfaces lose heat to space via radiation. A tree canopy blocks much of this outgoing radiation and reflects some back to the ground. This has been well studied in the southwest United States, where saguaro cacti can establish themselves at higher elevations thanks to nurse trees, as they're called. But the same basic principles apply to all of these regions. Basically, trees help new trees get established, in part by shielding young seedlings from the cold. And of course, they're also a shelter for many animals and insects. The Chaco was once dotted with millions of quebracho trees, which basically translates to axe breaker in English. Their valuable hardwood made them a target for timber harvests, and now they're much more scarce. Conservation of the remaining trees is essential because in an open woodland habitat, each of those trees is providing benefits that aren't immediately obvious. When you see one lone tree in a savanna, there's a lot more to it than what meets the eye. As always, the sources for this video are in the description. Thanks for watching. If you find these topics interesting, consider subscribing. There will be many more to come.